as the last problem was fg prime of 1. And the graph was given, and I'll show you the graph in a minute. We'll go to the graph. Well, please don't invent anything. You cannot say, oh, it's f prime of 1 times g prime of 1. But we discussed this. We have a product rule. We cannot just say, oh, I can come up with something. This has to be f prime of 1 times g of 1 plus f of 1 times g prime of 1. There is no discussion there. We cannot. As I said, it's too late for us to invent anything in calculus. So you cannot just say, oh, I'm just going to invent a formula. No. If this is a product, I have to use the product rule. If this is the chain rule, I have to use the chain rule. If this is a quotient, I have to use the quotient rule. And now how do I get these? So let's look at that problem for a moment. I'm going to share my screen. So that was, if you'd like to open, because I need the graph. Let me see, where was it? On page 164, please. At the bottom of 164. I always try to grade everything from class to class, because otherwise if I fall behind, then it will be tough to catch up. Okay, video, okay. Yes, so this was in section 1.6, chapter 1, section 1.6. I don't really need that. I can go anywhere and just punch in 164. I think we talked about it last time, but maybe not. Maybe I just looked at it during the study group, maybe. Okay, I'm sharing my screen. Where are you guys? I lost you. Okay, I found you. So 164. Now I need to find my keyboard. Got it. So now let's say I want that product, so it's at 1. So at 1, f of 1 is 2. So I will replace f of 1 by 2. At 1, g is, I'm going to consider 2.5. But now let's talk about the rate of change. So at 1, for f, see, this is the slope at this point. So at this point, not the slope, the tangent. So at this point, this is the tangent. So how do I determine the slope? It's a negative slope. So it's rise, which is 4, and run, which is 2. So negative 4 over 2 is negative 2. So f prime of 1 is negative 2. Now for g. So obviously, this is the point. The tangent is this, and the slope is positive. All I have to do is find corners of the grid. Okay, so rise is 1, run is 2. 1 over 2 will be 0.5. So then this is 0.5. And that's how, after I calculate, and many of you did it correctly, I'm grateful for that, I got negative 4. Okay, so please try not to invent anything and just say, oh, this is a product, I have to use the product rule. Okay, enough of that. What would you like to start with? Any questions on anything? What would you like to start with? Anyone? Any preference? Anyone? Oh, I just saw there is a chat. Okay, for me. Do you still want to look at 62? I just saw that in 1.7 was 62 in 1.7. Do you still want to do that? Did I lose you? Am I muted?
Yes.
Am I muted?
He answered yes.
So we're looking at 62 in 1.7?
Yes.
Okay. I thought I was by myself. Let me just get a sip of water. Okay. So we're looking at, sorry, my apologies, I just didn't see that. So we said 62. Again, it says in 1.7. Yeah. Okay. 62, 1.7, 1.7, 62. That is on page 172. So we're looking at the total cost, and the function is given to us as the square root of 5x squared plus 60. And it plans to boost production t months from now according to the function x of t, which is 20t plus 40. How fast will cost be rising 4 months from now? So t equals 4 months. Perfect question. So what I'm asked to find is c prime of t. One more time, let's read the question. It reads, how fast will costs be rising 4 months from now? Well, I cannot do this before I realize that I have a function of another function. So c is a function of x. Of course, they are throwing these variables at us, so make it as difficult as possible, but it's not. So cost is the outer function. X is the inner function of t. So basically what we have is this. We have c of x of t. And if I want to differentiate this, I will have c prime of x of t, that's the chain rule, times the inner function prime. So first, I will differentiate this with respect to x. Then I will differentiate this with respect to t, and make sure that at the end of the day, I only have t in this new function that I determine. I determine a new function. And I don't want to have t and x at the same time. I only want to keep t. Okay, so equals. I look at this c function, right? So maybe we should do it in 2 steps separately, and I'll come back here. So let's do first c prime. C prime of x will be 1 over 2 the square root of 5x squared plus 60 times the inner function prime, which is 10x. Is this okay? I don't want to lose anyone. Is this okay so far?
Yes.
Okay, then I simplify 2 with 10, and I get 5x over 5x squared plus 60, of course, with a square root on top. So I already have this piece. Now, not yet function of t. I have to replace everywhere I see x by 20t plus 40. 20t plus 40. 20t plus 40 squared. Let's do it right now. Or we can evaluate it later when we evaluate x. It's another way. There are many ways here. So 5 20t plus 40. Everything divided by, you don't need to calculate anything because we have to plug in 4, and that's all we're going to do. So the square root of 5, I replace 20t plus 40, everything squared, and plus 60. So now this piece here is this. And I'm going to use a different color for x. because this is really very simple. X prime of t is 20. So this piece is only 20. So the final answer for C prime, I can't find C prime of 4 if I don't have C prime of t. So this is at the end. Okay, so this, I have it here, times 20. So 20 times 5, 100, 20t plus 40, everything divided by this whole thing. 5, quantity, 20t plus 40, everything squared, and plus 60. This is where I am going to replace, in this expression, I will replace t by 4 months. Please remember measurement units. Please, I wrote so many times, please, measurement unit, please, measurement unit. Okay, so I'm going to put this function in the graphing calculator. So careful, I'm going to share my screen. Careful how you put it in. Because it's not easy. If you omit a parenthesis or something, you get a totally different answer. Okay, I'm sharing my screen. Where are you guys? I always, when I move from one thing to another, I always lose you. Okay, here it is. So in y equals, clear everything. And the numerator is okay. With 5, left parent, 20x. Yes, I know you're going to ask me, why do you put, it's easier for me. You don't, since it's only one value, you don't have to. You can even do it by hand, to be honest. So divided by the square root. I like to see the function. It's easier for me, but it may not be easier for you. So you can just plug it in. So I have parenthesis, I have 5. And again another one, 20x plus 40. Close power 2. Make sure that it's outside, plus 60, and close the parenthesis for the square root. So when I see the function and I'm happy with it, I go to second and table and I put in 4, and it will give us whatever. What does it give us? It gives us 2.2351. Now I have to think. What is this? It's the rate of change of cost with respect to time. So C prime of 4, we got 2.24. Okay, cost with respect to time. So what would be the measurement unit? Can anyone help with the measurement unit? So the cost, they say, is in thousands of dollars.
Would it be thousands of dollars per month?
Excellent. Two measurement units. You can write it as 2240, and then you can write dollars per month. That's fine too. Okay, same thing. Or 2.24 thousands of dollars per month. Good question, good problem. Okay, perfect. So what do we continue with? Oh, that's not, that's something else. Where is my, oh, yes, these two. What would you like to continue with from this list?
Can we do a little review on limits?
Yes, very good. So let's review limits. Good. So I will look at, let's say, at the beginning of chapter 1, before we looked at, so you want the definition of the derivative, or you just want limits in general?
Limits in general. Please.
Okay, so I found a first question. If you have something for us, you can choose, of course. So I don't know, 24 on page 124 caught my eye. So we have limit Sx approaches 2 from 3x squared plus x minus 14 divided by x squared minus 4. So here's a limit. How do I think about it? What do I need to do? What will be my first thought here?
You plug in 2.
Brilliant. So let's plug in 2. I will plug in 2 in the denominator first, and what do I get?
Zero.
Excellent. What about the numerator?
Zero.
Excellent. So there is hope. Furthermore, what do I know for sure?
X minus 2 is a factor on both of them.
Guaranteed. Guaranteed. If in case you forget, when we say x approaches 2, we really mean x minus 2 approaches 0. It's the same thing. Good. Great job. And then what do I do? Because they are both degree 2, I have to have a factor at the top and a factor in the denominator. Anyone would like to help here?
Factorize.
Yes. So can anyone give us these factors?
So the top one, 3x plus 7,
And the denominator?
x plus 2.
Good. In case you have any doubts, it takes literally 5 seconds or less to check this. Right? We know the formula. Let's say x squared plus 2x minus 2x minus 4. Check. X times 3x, 3x squared. Check. Positive 7x minus 6x. Check. Negative 2 times 7, negative 14. Check. 5 seconds. So you know for sure that you didn't make an error, because it's very important, right? If we mess up something here, then the answer will be incorrect. So yes, that's what we do. And now you can drop the limit operator unless you want to write it one more time. I have nothing against it. But now we drop the limit operator. I don't want to see something like this. Limit equals. No, please don't write this. Please, I'm begging you. So then now you're applying the limit, and what is the answer?
(13/4).
Excellent. Perfect. Okay, so here's another limit. Let's say I would like to look at problem 40. On the same page, 124. Ah, look at that. I'm writing without looking. So x approaches infinity, x to the 5th divided by x to the 3rd plus 4x plus 10. Somebody on such a limit, don't write it because of course says, oh, I'll divide by this. What does this mean? I can't just write something and then come up with an answer, right? I have to explain what I'm doing. And this is not what I recommend you should do here. Let me